Well, gang, what do we got on the docket for today? Section 1.8, Combinations of Functions and Composite Functions. Outstanding. So here's what we're going to be doing. We are going to perform arithmetic combinations of functions. You'll understand what that means in a second. And determine the domain of combined functions. I don't know what it is about me and the word domain. I can't just say domain. I always have to say domain. Anyways, perform composite functions, and that's going to be in the second video, I believe, and determine the domain of composite functions. All right, moving on. Arithmetic combinations are functions that are combined to create a totally new function, and the term arithmetic means that it can be added, subtracted, multiplied, or divided. So you've seen functions like f of x equals x squared plus x minus 2. You could consider that to be a combination of two functions through addition. You could have g of x equals x squared and h of x equals x minus 2. And when you add those two, you would get f of x. Okay? So the first part of section 1.8 is pretty simple. We're just going to be performing those arithmetic operations on functions and then simplifying them if need be. And the notation is kind of important for you to understand. The notation that you're going to see in the book is going to be f plus g of x. And that's basically just taking f of x and adding g of x to it. Same thing is true with subtraction. F minus g in parentheses is f of x minus g of x. Okay, f times g, or fg of x, is just f of x times g of x. And lastly, we have f over g of x, which is just f of x over g of x. So the top expression that you've seen in all these examples is kind of the shortcut notation of it. You get to save yourself one full x. All right, so let's do some examples. We have f of x and g of x here, and I want to perform all four of those operations. We're going to do one at a time. So we're going to start with f plus g of x. Okay, and like I said, all you're going to do is take f of x, add g of x, and if possible, simplify it from there. That's it. That's all there is to it. All right, let's try f minus g of x. All right, same thing, 3x plus 4 minus x squared minus 2. I would caution you to keep the terms in parentheses, because sometimes if you don't, you forget to distribute that minus sign to the negative 2 as well. And that's it. Okay, for f times g of x, you're going to be doing distribution or foiling. This is my cat. She wants to bother me right now. It can't be done. Just kidding, I didn't throw her. All right, so distribute those. Simplify if need be, and in this case we want to get our powers in descending order because that's standard form. So there we go. And the next one is division. Okay, now when you get that right there, if it can be simplified easily, then go ahead and do it. All right. Sometimes they can be simplified pretty easily. There might be a trinomial in the denominator that can be factored and something can be canceled out, but Don't spend 15 minutes trying to simplify something like that. It should be easy to do if it's possible. All right, now we're going to talk about the domain of combination functions. And thinking back to when we were talking about domain earlier, there were only two things that we really concerned ourselves with. You can't divide by 0, and you can't have an imaginary number. So anytime you had a quotient, you had to be concerned about whether or not the denominator could be 0. And anytime you had an even radical, you had to make sure there were no negatives underneath it. So that's what you're keeping in mind, even with these combination domains. Because the same rules apply here. If you think about the first three cases of arithmetic combinations, addition, subtraction, and multiplication, whatever the result is, it's going to share the same domain as what the original functions had. And I did say functions because you have to be conscious of both domains. So what I mean is, if the domain of f of x is all reals but x cannot equal 4, and the domain of g of x is all reals greater than 0, okay, then the domain of those three combinations, addition, subtraction, and multiplication, will have the same exact domains as both of those, which would be all reals such that x is greater than 0, but x cannot equal 4. So your combination is going to include both the domains that the original functions had. In the case of division, the same thing is true, but we have to consider one other thing, and that is, since g of x is in the denominator, we know that g of x cannot equal 0. Okay, the domain for both of these two functions that we used earlier was all real numbers, which means that for the first three combinations, f plus g, f minus g, and f times g, the domain is going to be all reals. However, when we get to f over g, we have to remember that g of x cannot equal 0, which means you would set x squared minus 2 not equal to 0, and that would mean that x cannot be plus or minus the square root of 2. That's all you need to know about combinations, arithmetic combinations. Adios.